Hello everyone, this is Mr. again, and this time I'm going to demonstrate in this video lesson uh, how to create a hub and the support structure for the vertical wind turbine blade. And when you were away from your screen, I generated this image, but I'm going to redo it again one more time and to show you that the procedure. Basically, the vertical wind blade, turbine blade is on the right hand side. You get the seat in the way, and you have a hub. Okay, it's a cylindrical hub, and at the center of the hub, there is a hole. Okay, and this hole extends. Hub itself is about 1 inch long and half-inch in diameter, and the hole itself is an eighth of an inch thick, but it is a cone, and the cone extends all the way to half-inch, okay, to the middle, halfway. And also at the other end of the hub, there is a cylindrical protrusion. Again, it's about a quarter of an inch diameter, okay. And all of this are supposed to be unioned or welded together, okay? And the command is union, and I did not apply the command, but it's the easy part. So you just simply type the union, okay, and enter, and then join the turbine blade to the supports. And I have 1, 2, 3, 4 supports, okay, and the hub and the extrusion, hexagon extrusion, okay. And supposedly, all of this should be connected to a joint at the end of the generator or electric motor, and which is going to be directly connected to a pole. Okay. All right. So I'm going to hit Enter key, and everything became as one single piece. Okay. Good. So dimensions are important, and I need to mark these dimensions for you. And the hub itself, we said, uh, 1 inch long. Okay, diameter is half-inch. Okay, you have 1/8 of an inch. Uh, 1/8 of an inch cone hole. We're going to subtract that. We're going to create the cone, then subtract it, and the height of the cone is going to be half-inch height. Okay. At the other end, what is the diameter? Diameter is going to be half-inch diameter of the cone, and you have quarter of an inch protrusion at the end. That is your axle. Okay, about, again, it's a half-inch protrusion. Okay, so that should take care of the multiple things that we're going to do, those dimensions. Okay, so let me turn on the layer that I prepared for you earlier in the previous. I created a brand new layer. By the way, the layer dd layer command enables you to create layer, and I have frozen it so that you can see on the right hand side. Okay, and I'm going to freeze this particular layer, and layer controls, okay, will enable you to disappear or appear certain layers. Okay, close. So in order to make a layer current, you need to double click the layer name, double click. So again, name layer became the current layer. The concept of current layer is the one that you generate the lines or 3D objects or surfaces on the current layer. So whatever the current layer is, it's going to take after all the properties of the layer, including the color. Okay, So now I can turn off the layer 1, which was the default layer. Okay. Even this line should be on layer 1. How do I change a layer of an existing line? That's also a learning piece, important learning piece for you. You go type change command, enter, and computer will ask you what to change. You want to change the properties. You click, select the properties, select the layer. Okay. And now it's asking you the layer name. And the layer name is supposed to be layer 1. It's not 0. So I'm going to try layer 1. Okay, I'm sorry, capital A. It has to be case sensitive layer 1. Okay, enter and enter. And disappears because layer 1 is, I have freeze there layer 1. It's frozen, so it disappears. But the current layer is Ege layer, and Ege layer is incomplete drawing that I'm going to demonstrate in a second here. Okay. The only thing is hub is not created. Hub is created, which I didn't intend to be. I'm going to delete that too. Okay, deleting this hub. Okay, and these lines you already have in your drawing. Okay, you already have the 6-inch long line. You have the protrusion lines and so on. Okay, these are the lines that rotated 24 degrees. And I'm just going to go it's just by UCS right here. Okay, I'm going to put my type UCS command, enter. And in order to create a cylinder, probably I should manipulate XY plane right at the center. So it's asking me where to find it. Midpoint, actually, where I find it. The midpoint is a triangular. It shows a triangle. If I can, yes. This is your, is this the midpoint? 1, 2, 3, 4. I think this is the midpoint. Okay, click and enter. Okay. And so far, so good. But again, because I'm going to generate this a cylinder, Z should be parallel to the center axis. So how do I rotate the Z? I should rotate the Z around the Y axis. Okay, so that Z is parallel to the center line. Okay, so enter again, UCS comes back, and type Y, enter. It suggests you 90-degree rotation, which is fine with me. Enter again, and Z now perpendicular. That's a good news because XY plane, I want the XY plane to be flat horizontals because I'm going to create the cylinder. So command is cylinder. How do you type cylinders? SYLINDER, enter. Okay. And the center point happens to be 0, 0. I already adjusted that ahead of time. Okay, it's huge cylinder. You don't want that much. How much do you want to be? It's asking you the radius of the cylinder. We want the cylinder diameter to be ½ inch. Radius has to be half of the diameter. If the diameter is ½ inch, radius has to be 0.25, right? So I'm typing 0. Or just 0.25. Enter. Ta-da! So cool. Now it wants to go up or down. Okay. We can go take it down a little bit. Right. And how much do you want it to go? 1 inch. So I'm typing 1, enter. Cool. So this is nicely, beautifully done. Conveniently also done. So what else do we need? We need a hole. Okay. And the hole is going to be in the shape of cone. And cone has to have a also diameter, radius, and the height. Height is going to be half of the total height, which is ½ inch. The width, I want it to be 1/8 of an inch. But the axle of the generator I have a lot of little motors, and electric motors works as a generator as well. With the axle of 1/8 of an inch, this should be slightly larger than 1/8 of an inch. Okay, So what are we talking about? If we're talking about 30 seconds, okay, what is 1/8 of an inch is equal to in terms of 30 seconds? Okay, 32 divided by, so 4 30 seconds of an inch. I want this a little bit larger. So we're talking about, instead of 4 30 seconds, 5 30 seconds of an inch. So 5 30 seconds of an inch gives me slightly larger hole. Okay, why is it important? It is important because computer is going to ask you, okay, the diameter or the radius of the cylinder, of the cone command. So I'm typing cone right now. Actually, you know what? Right now, the shade mode is solid, realistic. I'm going to change the shade mode so that you and I, we can see better. Okay, right now the solids are blocking our views. So let's type shade mode, SHADEMODE, enter. Okay, let's go to 2D wireframe. Cool. It's more visible now. Let's go with the cone command. Cone is spelled K-O-N-E. Everybody knows that, right? So cool. 0, 0. Enter. Okay. Now computer is asking me the radius of the cone, circle of bottom of the cone. The radius, okay, is 5 30 seconds of inch. No, it's the radius is going to be 5 64 of an inch, half of 5 30 seconds of an inch. So what is 5 64 of an inch is equal to, in decimal, we have to convert 5 by 64. Does somebody have a calculator there? And I hope you do, because calculators are essential in this class. 5 64 of an inch, 5 divided by 64, is equal to 0.078, 0.078, approximately. There's a long number, 78125, but I'm just going to get. So I'm typing, it's asking me the radius, not the diameter of the circle. So that is fine. Engineers deal with the mostly diameter when they're dealing with the circles. But this is AutoCAD, so we have to go with the AutoCAD. So 0.078, enter. Now computer is asking me direction. Move your cursor down so that you can show the direction. Direction is 0.5 inches, so type 0.5, enter. Ta-da! Okay. So it is done. So you have two solids, okay? You have the hub, you have the cone inside the hub, but we need to subtract this cone from the hub. So command is subtract. You type subtract, okay? If you wish, you can find subtract command on the menu. That's not the problem. Select the object, select the large object for subtraction. Select big object, enter key after you click on it. Now select the smaller object. Smaller object will be the cone. Move your cursor carefully. Just pick the cone only, enter. And I believe the subtraction is made. How do I know? When I move a cursor over the cylinder, it picks the cone as well. So you save your work at this point because you accomplished. Good. Now we need the protrusion, hexagon protrusion. What is that protrusion for? Protrusion can be useful. Okay. And attach it onto another hub, or perhaps a ball bearing. The ball bearing makes everything rotate so much faster without the friction that increases. So I'm thinking ahead of myself. And there will be a ball bearing that perhaps increases the speed of the rotation of the vertical wind blade. And that's why I have a hub, okay, hexagonal protrusion over there. To create this at the bottom end, I'm going to change my UCS. Okay, I'm typing UCS again, enter. And it should go onto center. So I'm typing CEN, okay, for center. Select the center of the circle at the bottom of the cylinder, enter. enter again. Okay, now I'm ready for to create a hexagon. How do I ask for hexagon from AutoCAD? I'm not going to type hexagon. There is no such command as hexagon. And so I'm going to type polygon. So poly, P-O-L-Y-G-O-N, enter. It's going to ask me number of sides. Hexagon has 6 sides, so I'm typing 6, enter. Okay, now it's asking center point, 0, 0, enter. Whether it's inscribe or circumscribe, okay, and it gives me a better control over the size of the hexagon. C, enter. Okay. Now computer is asking me the radius. This is going, because this is going to be ½ inch and half of quarter inch, half of the quarter inch is 1/8 of an inch, so 0.125, enter. Okay, and I'm going to extrude this hexagon. So command is extrude, E-X-T-R-U-D-E-E, enter. And select the last item. I can move my cursor, L for last. I type L for last instead of clicking on it. You can click on it if you want to, or type L for last. Okay, select the object to extrude, enter. Now it's asking me extrusion direction. Let's go ½ inch. That's not the problem. Okay, so I'm going to go 0.25, okay, and enter. Now, why did I stop right now? I'm thinking maybe ½ inch. ½ inch is a better number. ½ inch could be a better number because it's going to be inserted into. Let's go Control Z this. Okay. Let's control or extrude this again. Press pull. We can do that too. Or Control Z. Let's extrude it one more time. Okay. Extrude. T-R-U-D-E. And last item. Enter. And extrusion. Specific the height of extrusion. Let's go with the 0.5 inches height. 0.5. Okay. That's better. Now that it's extruded, it needs to be connected with the union command to the main hub. So I'm typing union command. I'm more comfortable with the ½ inch direction. Okay. So click on this and then click on that. Okay, the hub, enter, both are connected. Save your work because you accomplished something. Okay, or I accomplished something. Okay, so this is done. Cool. What else is there? We need to connect these supports. Okay, so first of all, I plan to use those lines as supports, first of all, okay? And it's important. And how do we do that? We don't need so many supports, whole lot of them, okay? But we need plenty of supports, but not so many of them. So I am suggesting, okay, some supports we can erase. For example, we don't need this support. We can delete that. It's too many of them. And we can literally delete this support. Okay. Okay. But on the other hand, we can create some supports, okay, more intelligently. For example, this support. And by the way, my object snap is extremely important. I want to demonstrate endpoint, midpoint, center point are selected as object snap. That finds me a particular point accurately on the space. Also, nearest point is turned on. Please pay attention. Nearest point enables you to cursor to find any point accurately on existing line. This is a huge advantage, and you will see yourself. Okay. For example, if I move my cursor a little bit from here. Uh, I'm just going to click on this one of the support lines. Okay. Let's click on this particular support line and zoom in and pick the end of the line. End of the line you have control points, and pick any point halfway, somewhere around here on the existing line. Okay, same line. Escape. Click on the next line. Okay, click on the end of the line which gets red hot and pick it halfway so that. All right, so we're shortening basically those lines, and we can do the same thing. Select the line over here. You can move it like over here at the end of the, perhaps zoom in, perhaps here. Okay, click here same way. This is the top support, and there is going to be click on this one, and then you're going to move to, oh, we don't need this because there is already a line. Click on this one, delete. We don't need that line. Okay, we're good so far, so good. 1, 2, 3 supports. Okay, that's maybe we should have one more support here. Click here. I wonder if I could click on this one and click the line, escape. Okay, what I would like to have is 4 lines, 4 supports instead of 3 supports. So another one over here, and that needs to go, that end has to go perhaps a little bit higher. Okay, and that I can do. Maybe here. Cool. Okay. Now at least we have 4 supports. We can add another line support somewhere in the middle. But 4 is enough, I think. Yeah. We could add another line somewhere before we reach. Escape, line command. Click, and then zoom in and pick the end. Okay. And that didn't go direction I like to have it. Zoom in, click on the line, select the control point. Control point gets red hot when you select it. Then move at the end of the next support line. Okay, now we have 5. I think this should be strong enough. Okay. Now we need to create profiles. We need to create profiles so that we can extrude those profiles. Now to create a profile, I'd like to have the profile at the angle of, so I need to move my UCS at the same angle with the blade itself. So I'm typing the UCS, enter, okay? And I'm picking the bottom point of the UCS and second bottom point on the UCS so that my X, and enter key. So my X is aligned, okay? X is aligned, but how about Z? Is the Z perpendicular? XY plane is aligned. This is a good news, okay? Now we need to rotate Y plane around the X coordinate. So I'm typing UCS, enter, and I'm typing X, enter, and enter again so that entire UCS, user coordinate system, is rotated around X plane. Cool. Now I'm ready to create an ellipse. Ellipse is big deal. Why? Because extrusions are going to be based on ellipse. Okay, that we are generating. Um, I'm going to rotate this UCS one more time because I want this to be parallel, the profile to be parallel to the bottom. Okay, so type UCS, UCS, enter, and X, enter. Okay, all right, I think it's far better now than it was. And now type ellipse. Ellipse command is in the already ribbon, but and it's asking us the distance. Okay, so we're going to create the long distance first, and then short distance next. Okay, and I'm going to move the ellipse from its center point. Enter. And CEN, if you type CEN for center point, computer will pick the center point of the ellipse instantly. Move ellipse again. Select the ellipse again. Type CEN for, okay, and move cursor. Okay. And now you're picking the bottom line. Okay. What do we do so far? Is the ellipse correct size? I'm checking on. Click. Is the ellipse correct size? Can we make it a little bit larger? Okay, I'm going to be 2.5. Okay. I think this will work. And it's going to be a little bit wider, perhaps. Maybe. Oh, Control C. That's so much. Okay. So that ellipse is going to be extrusion profile. So I'm going to, well, maybe we should click. Click. Okay, a little bit wider is better. Okay. So I'm going to move it from where it is, or copy it at least. So CP for copy. Select the ellipse, enter, and type CEN from point CEN, from point, which is center of the ellipse. And now you want to move it to at the end of the first support line. Click. And you can go like that, okay? But I want to show you the effect of this. So let's go and extrude. Command is extrude, E-X-T-R-U-D-E, enter. Select the ellipse. Okay. Enter. Now, computer gives you a bunch of options. One of them is path option. You select the path option. Okay. So how did that go? I want to change the shade mode. Shade mode, enter. And go with the realistic option. Okay. All right. Orbit command, maybe. We're going to see how the ellipse is positioned. Okay. The support is positioned. Okay. All right. So not too bad. Escape. Okay, Z enter, P enter for previous view. Okay. And I'm going to ellipse. Okay, continue. I'm going to continue with the extrusion of the ellipse. Okay, so extrude. Okay. EXTRUDE. All right. And the select the ellipse correctly. Enter. Select the path option. Enter. Okay. Cool. All right. So um, I'm going to just simply copy. Okay. CP for copy, and select the ellipse, initial ellipse. Enter. And CEM for the center of the ellipse. So select the ellipse, touch the ellipse. It will show you the center point. Then click. Okay. And move your cursor. And find the end of the line. Click. Find the end of the line. Click. Find end of the line. Okay. So let's do the extrusions, of course. And in the meantime, save your work. Again, EXTRUDE. You can literally find the extrusion on the pull down menu. That's not the problem. It's just that it's too easy for me to do this, okay, by just typing the name. So select the first ellipse here. Enter. Okay, and select the path line. Click option, path line option. On the command line, click. Okay. Enter again. Select ellipse. Extrusion command comes back. Select the ellipse. Enter. Path option. Select the path. Okay. And enter again one more time. Click on the ellipse. Enter. Path option. And then select the line. Cool. Okay. And now we have done this much. So cool. What else do we need to do? Let's check it out, what we have done, what we have accomplished, right? So how do you check this out? Save, of course. Type shade mode, find out, and go to realistic option. Okay. And orbit command, and examine your work. Okay, so one line is way off. See this? It is not supposed to be where it is right now. So how do we fix that? Okay, we need to go back and Control Z. The one in the middle did not work out well. So Control Z, Control Z. We're going to have to go back and to the point where that extrusion is done. So this line was off, way off. So what do we do? Click on the end of the line. Drag it to the end of the extrusion line, other extrusion line, right here. Okay. Now let's see if this is going to be extruded in a correct direction. Right? So extrude again, XTRUDE, enter. Enter. Once you enter, command line options changes. Select the path option, select the line, click. Okay. Enter again. Click. Enter. Select the path option. Enter. Very good. And save your work. Now, I'll do the saving a little later. Okay, I just wanted to see again, observe we have issues or not. Okay. Shade mode. Enter. And choose realistic option. Okay. And this time it looks right, but You never know. Orbit command to turn around and check it out if there are any mistakes. And mistakes do happen all the time. I mean, you may be perfect or you believe you're the perfect person in the world, but that we all make mistakes. And engineering is about reducing the mistakes to so small that you can ignore them. So negligible. These mistakes has to be at negligible levels. Okay. Now you realize there are certain part of the supports are sticking out. Okay. That also can be corrected later, and I will show you there is a way to do this. Okay, you can cut through and make this top surface very clean. There is a way to do this, but for now, okay, I'm going to end this lesson, this video lesson. Okay. Before ending the video lesson, let's do one more thing. Okay, so let's save it first, our work. Why did we do this? We did this because we want to make 3 of these. How do you make 3 of them? Okay, so go to the plan, to the top. Notice that your XY plane has to be at the center. So type UCS again, enter. Try to pick the center of C and enters. And try to pick the center of the circle or hub, click, enter. Okay, now your Z is perpendicular to your view and also at the very center of everything. So we created this from the beginning as 1/3 of the Act3 blades, right? So how do we do it? Array command. Let's use array command, enter. Select the object, and this is pretty much, we need to use union first. So union, use the union, select the entities one at a time. And the hub. Is there anything else to select? Yep, everything is done. And all selected, enter. Okay. Now use array command. Select the object, enter. Is it a rectangular or polar array? It's a polar array, circular array, enter. Axis of rotation. It is a C and enter. Okay. It made all of a sudden multiple copies. So go to items. All we want is 3 items, 3 enter. Okay. I think we're all good. Unless you want to take a look at this. Yes. Cool. Enter. We're done. Save your work. Okay. Now, we're going to continue this project in the next session, but this is the end of the lesson 4. Okay, video lesson 4. And thank you very much for your attention. Let's give it a try, and if you have any problems, call me. Okay, have a great day.